Objectives of the students. The students in the seminar should be familiar with the working principle of fluid energies. The students should get knowledge about physical and thermodynamic background and the evaluation of fluid energy machines and thermal energy systems. The students should also get basic knowledge of the simulation tool SimCenter Amazon. SimCenter Amazon, you should be able to to solve your equations and to make your exercises on a sheet of paper with some tables, for example, or your calculator. But on the other side, in industry, we have a standard. It's SimCenter Amazon, where you can create big thermal energy systems, you can create components, you can create pumps, turbines, and you should learn this tool. It's not so difficult, it's an easy tool, it's graphical programming. I think it's easy to learn and it's charge-free. You can download it from the internet. And also, last point is you should learn English. Yeah, you should you should be able to express yourself in English. You should be able to have technical discussions about fluid energies in English, and especially in SCAP meetings or in team meetings. Yeah, it's a good practice for your daily life as an engineer. So, let's have a short look. We can separate fluid energy machines and thermal systems in flow machines and displacement machines. Yeah? Flow machines are gas turbines, steam turbines, radial compressors, rotary pumps. In general, one part is rotating and you have high velocities of the fluid, whatever it is, water or gas or steam. On the other side, we have the big group of displacement machines. The displacement machines work with a piston. Big family of displacement machines is, for example, diesel and auto engines. Car engines are displacement machines. I've been working at Bosch for over 7 years in the field of diesel engine development. And another big group is so-called steam piston expander. Piston expanders are not so well known nowadays, but they have been very much well known in the past at steam locomotive engines. Yeah. Okay, we have piston compressors, or we can have piston pumps. I think you all know a piston pump for air. For example, for your bicycle. Yeah? When you pump up your bicycle, this is a piston pump. Okay, that's the two main groups of machines. And the special thing at piston or displacement engines is that you don't have so high velocities of the fluids. Okay. Another point is we want to look at the system. On one point of the component, we look on the component, on the pump, on the propeller, but on the other side, we look on the system and we must make balances. Huh? Okay, when you have a fluid energy machine, there will come chemical energy, or there will come any form of energy, velocity will come into the fluid energy machines, and then you have a second mass flow and a second part of work or of energy will be taken away. But you will always have some parts of heat that will be produced by this engine. Yeah, more or less, most cases, waste heat. Okay, and on the other side, we could have could make balances of power. Yeah? So we can sketch a kind of power flow chart, and then we balance the power. The power is a derivation of energy. You see it here, W dot for work, derivation of time. And here always we can have a heat flow that comes outside the system, but in general we will also have a part of power that is being used, for our purposes. Okay, that's in general what we should do here. Okay, I've shown you that we can divide the fluid energy machines in piston machines and in flow machines. Yeah? But there is also another possibility to divide both types of machines. We can divide the fluid energy machines in power machines or in work machines. And if we divide it in power machines, yeah, we can say we have, for example, power machine is a water turbine. Yeah? Water turbine, you have a flowing fluid, water, and the energy is stored in this flow of the water, and then it comes into the turbine and will be converted into electric power. Or for example, steam and gas turbines are also power machines. Steam or gas comes into the turbine, it will be burned or expanded, and then we get electricity or movement of the gears. And we can have windmills. Windmills are really simple example of power machines. The wind is flowing, the air is flowing, the rotor of the windmill will rotate, and we get electricity from the generator. So the other here, this other part of fluid energy machines, if we look, that are work machines. Yeah, work machines can be, for example, ventilators. Ventilator looks a bit similar to a windmill, but the principle is totally different. At a windmill, we have moving air and will generate electricity, and it's vice versa. At the ventilator, we have electricity and then moving propellers, and then we get moving fluid, the air. It's totally vice versa. Also with the compressor, we have a movement of an engine or of an